All right, today we are going to have lesson 4.3, and we are starting on page 222 with these 4 do now problems. Let me get them nice and clear for you so you can pause your video if you don't have your book with you today. Okay, let's go over those problems. So the first one is a division problem. And so we want to know the cost per pound. So we have to divide by the amount that she bought. So here we have a decimal. And so we need to get rid of the decimal because it's in our divisor. So we're moving it once, but when we do that, we also move this one once. So when I go ahead and multiply, I get 98, and then I put in this decimal and I actually added a 0 so I could go to 98.5. Or 985, and then I pushed up my decimal, which made that into $9.85 per pound. So that's a division problem. Remember, you can add zeros after the decimal. It won't change the value. And then making sure that you remember to push your zero straight up to the top of the division problem. All right, here we have a multiplication problem, and so when we set this up, we notice that we can simplify on the diagonals. So I did that. 3 goes into 3 once, 3 goes into 9 3 times, 2 goes into 2 once, 2 goes into 10 5 times. And I multiplied the top and bottom and got 3/5 pound of flour. All right, so it says Gina draws a map of her town on a coordinate plane. The point that represents the town's civic center is 1 unit to the right of the origin and 4 units above. So 1 unit to the right, 4 above. What are the coordinates of this point representing the civic center? So remember, you always do your x first. This is our x-axis. This is our y-axis. X is a positive 1. And then we're going north 4. So our y, our second digit, is the 4. So positive, positive, over, up. All right, here we have Stefan who draws these shapes. What is the ratio of triangles to stars? So we have two triangles, 5 stars, so 2 to 5 or 2 to 5, or you could also write it 2 to 5. Okay, so moving on to the main idea of our lesson today, we're going to be looking at some more patterns in equivalent ratios. We're also going to talk about how a multiplication chart will help you find these patterns, and how when you're finding the patterns, these are multiples of a number. And so on your multiplication chart, I think I'll start with this part. If you look, these are all multiples of 3. These are multiples of 4. Also going down, the same thing, right? These are all multiples of 1, multiples of 2, multiples of 3. So you can look at it either way, but on your multiplication chart, when you go in a column or a row, those are multiples of that number. So you can use your multiplication chart on this today, and that will really help you. So let's go over a few here that we found, that I found on your assignment. Here we have the number of bags and how many apples are in a bag. So if we have 2 bags, that's 2 times 1 is 2, then the apples will also increase by 2, right? So here, if we wanted to, we could just fill out the multiples of these numbers in order to find these ratios. So this would be 3, 4, 5, going up by 6 times 3 is 18, 6 times 4 is 24, and 6 times 5 is 30. So these are all equivalent ratios. Depending on how many bags you buy, you'll get an increase in your number of apples. And if each bag has 6 apples, it's going to increase by 6 each time. All right, let's try that with these numbers, pretending that we have 7 apples per bag. So here we would multiply by 2, then 3, then 4, then 5. 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, and 7 times 5 is 35. All right, you guys pause this and try this one. If you haven't tried one of these, try this one on your own. Shouldn't take you very long. We'll try it together. Okay, take a peek and see if you have the same answer I have. Here, we're just doing the multiples of 1, and here we are doing multiples of 4, so it should be 4, 8, 12, 16, and 20. So this isn't too difficult today. I do want to go over a couple more problems just to make sure that you understand exactly how they'll be written here in your assignment on Think Central. So it says use a multiplication table to write two ratios that are equivalent to 4/7 or 4 over 7. Oh, here, I'm going to put this multiplication table right next door here so you can see it. We're going to do 4 and 7, so we're going to need this chart. So here's my 4s. I can go 4, 8, 12. Here's my 7, 7, 14, 21. So we can just do, my 4 would be 8, 12, and my 7s would be 14, 21 as I go up. So I'm going to make sure that I multiplied by 2 here, 2 times 2, that works, and then by 3 here, 3, and times 3. Okay, so that's how you'll use your multiplication table. And I know my multiplication, and a lot of you know them too, so you can just go ahead and count by 3s and count by 7s for this one. So 3, 6, 9, and 7, 14, 21. Here we would have 5, 10, 15, 2, 4, 6. This one is a little more complicated, right? Because you have to go to the lower one. So we're going to have to simplify this first, which would give us 1/5. So 1, 2, 3, 5, 10, 15. Whenever you see one like that, like even this one right here, let's jump to number 6 because I think you're understanding this. But this one, we want to simplify it because that'll give us that first lowest terms fraction. And simplifying it's really good to get some practice simplifying. So I see both of these are even. Now I could probably fit in a number larger because I see 3 would fit, but I'm just going to start with that because it's even. So I get 6 over 15, and I see 3 would also fit in both of these numbers. And if you didn't know how to find that out, let me just show you this on a multiplication chart. If you can find 6 and 15 on the same row, see here I have 6 and a 15 and they're on the same row, you can divide by the number that is the multiple of those numbers. So there I could find out that I could divide by 3 because I find 6 and 15 on that row. Same if we did the 12 and 30. So 12 and 30 are both on the 6th row, right? So I could have just started by dividing by 6. If I divided by 6, this answer would have been 2. If I divide this by 6, it would be 5th. So let me just check. Divide this also by 3 because we're going to make sure these are equal. 2 over 5. So that is how you can get 2/5. So that's one of them, 2/5. This was another, 6/15. That's another. These are all equivalent ratios. You could also take this one and multiply it by 2, 24 over 60. That would give you an equivalent ratio. There's lots and lots of equivalent ratios, an infinite number of equivalent ratios, but you want to keep it kind of close to 1 just so that the answers aren't going all over the place. So start with 2 and 3 and 4 and make sure you're simplifying. Stay really like close to small numbers, not making huge numbers unless that's what they're asking you for in the program. Okay, so good job. Well, good luck, and you can start your Think Central assignment.